Okay, so now we're ready to talk about the electronic structure of an atom. That is, we're ready to talk about how the electrons are organized in an atom. And this is going to tell us how atoms are going to act. So it's really powerful. All right, so first of all, we'll talk about electron energy levels. Now, the lines, which I showed you in a previous conversation, of an atomic spectrum are associated with the changes in energies of the electrons. In an atom, each electron has a specific energy known as its energy level, and it's assigned the following values. The lowest energy level is 1. The second lowest is 2, and I think you get what the trend is here, right? So, and the symbol we use for this is N, and the name for the energy level is the principal quantum number. Okay, the principal quantum number N is equal to 1 for the lowest energy level. All right, this increases in energy as the value of N increases, as you might have figured, and it also means that the electrons are further away from the nucleus. So the higher the N is, the further away from the nucleus an electron is. Okay, the energy of an electron, this is bizarre now, the energy of an electron is quantized. That is, electrons can only have very specific energy values and nothing in between. So a good way to think of quantization is thinking like a bookshelf. So suppose you've got these books here, where you've got 2 books down here where N is equal to 1. So here's the lowest energy level. Lowest energy level. Or shell. Okay, it's the first shell. It's the lowest energy level or the first shell. And there might be 2 books on it, right? Well, you could take one of those books and move it to N is equal to 2, but you can't move it to N is equal to 1.5. There is no 1.5, right? It's only a first shelf, a second shelf, a third shelf, and so on. And that's what we mean by quantized. Now, if we have changes in energy levels, that is when an electron moves from one energy level to another, right? So in this case, you've got an electron here, idealized as a little blue sphere, right? So you've got an electron here, and as it goes to the next energy level up, energy is absorbed by a photon. Okay. Now, if it goes from a higher energy level to a lower energy level, then it lets off energy as a photon or a little packet of energy. I referred in a previous conversation to particles of energy. So this would let off some energy if it drops from a higher energy level to a lower energy level. Now, the further they drop, the higher the energy. And you see I've got the red here is a big wavelength compared to the green. See, this is more tight. That's because it's a bigger drop. And so you have a higher energy photon emitted if you have a big drop. If you go from a lower energy level to see this spacing here is different than this spacing. A big spacing, it's going to require a lot of energy to be absorbed. All right. So now we talked about levels. Let's appreciate now that levels actually have sublevels. All right, not all of them do, but many of them have sublevels. So or sub shells, right? Okay, it's the arrangement of electrons that determines the physical and chemical properties of an element, and this is why it matters. Okay, each energy level consists of one or more sublevels. The number of sublevels is equal to the principal quantum number of that energy level. The sublevels are called S, P, D, and F. The order of the sublevels are this. S is a lower energy than a P. P is lower energy than D. D is lower energy than F. All right. So I think I drew for you in class a diagram for this called the diagonal rule. And we said that 1, the first level, N is equal to 1, has 1 subshell, and we call it S. The second energy level has got 2 subshells, and we call them S and P. Right? You think you get what's going on here, right? The third energy level has got 3 sublevels or 3 subshells, and we call them S, P, and D, and so on. All right. So, and here's another picture of that from your textbook. For N is equal to 1, you've got 1 sublevel and or one subshell, and it's an S. For n is equal to 2, you've got two sublevels, and they're S and P. Okay? And by the way, these boxes represent how many orbitals, which is coming up in the next slide, how many orbitals each of these have. This S subshell has got one orbital in it, so it's got one yellow box. P has 3 orbitals in it, and so it's got 3 green boxes. Okay? D has 5 orbitals in it, so it's got 5 orange boxes, right? 1, 2, 3, 4, 5. All right? So the sublevels are described here. Orbitals, as I said before, are within the sublevels. Okay? That is, there's more places where the electrons can reside. So an orbital is defined as is described by the probability of where an electron is going to be. So an s orbital is spherical. S orbitals are spherical. So can you see a sphere right here? And since it's spherical, that means that when we go to look for an electron inside an atom, we find that it is spherosymmetric, right? So can you see how this is a cloud here? But the cloud itself is spherical, right? We oftentimes draw it as if it were a ball, but it's really more like a cloud. All right, so s orbitals are spherical. P orbitals are not spherical. There are 3 p orbitals, right? And the lowest energy level that has a sublevel of p is 2, right? And each p orbital has 2 lobes, like 2 balloons tied to each other at the hole, or like a balloon tied in the middle. It can hold a maximum of 2 electrons. All right, the 3 p orbitals are arranged perpendicularly to each other, which I'll show you in the next slide. And we consider you can think of them like the three-dimensional Cartesian coordinate system you learned in algebra. So, right. So here's 1 p orbital. Here's 1 p orbital. We might call it p sub x. That would be a good name for it. Can you see why it might be called p sub x? So the lowest one is 2. Doesn't have to be 3. 3 has the 3p subshell also has orbitals that look like this. Okay, but it's arranged along this axis here. This is only one orbital. Okay, so you have an electron, or you have 2 electrons a maximum, and they could be anywhere. They're not necessarily one on either side. They're really spinning all there the whole time. Okay, here's a 2p sub y, p sub z, and if you put them all together, the picture gets kind of busy, right? So that's why it's good to kind of think about them individually. But this would be a good sort of graphic to demonstrate where the electrons can be if they're in a p subshell. All right, D's are even more complicated, and F's are more complicated yet. I'm not going to say anything about that. These are all the different 5D orbitals, and if we put them all together, you can imagine it would be really, really complicated, hard to see what you're looking at. All right, and then finally, I want to say that each orbital has a capacity for 2 electrons. Each orbital has a capacity for 2, and the electrons in the same orbital repel each other, and they have opposite spins. So oftentimes we'll draw an orbital as a box, and we'll draw one arrow up and one arrow down, right, representing the 2 different spins. Okay, so there's a maximum number of electrons that can fill each sublevel because we know how many orbitals are in each sublevel, right? And every orbital can have 2 electrons. So the S can have a maximum of 2 electrons because it only has 1 orbital. P has 3 orbitals, so it can only have a maximum of 6 electrons. D has 5, so it can hold a maximum of 10, and so on. I think you get the point. So here's a graphic from your book. I'm not going to walk through this with you. It's just got a sort of a summation of all the information which I've told you previously. Okay, so let's round this conversation out with a learning check. Pause the video, look in your textbook, and see if these questions are easy. Okay, so let's come here, and so I'm going to suppose you did pause it. Let's do A. Indicate the type and number of orbitals in each of the following energy levels or sublevels. Okay, so if n is equal to 1, then we know that it only has 1 subshell in it, which is equal to S. So I'm going to call it at once 1s. That's the subshell. Now, how many orbitals are in an s? There's one orbital in an s. Okay? And by the way, I didn't ask this question here, but there are 2 electrons in that one orbital, right? Okay, so let's go and do the next part, B. I didn't really leave myself a lot of space here for B. A 3p sublevel, right? So a 3p sublevel, because it's p, it has three orbitals, right? Which I'm going to draw as boxes, and each of them, right, can have a capacity for 2 electrons. So it's going to be 6 electrons total. Okay, and that is it for this part of the conversation. My recommendation is to come back to it, and if this is not clear, come back to it another day. Take good notes on it, and come back and think about it overnight, and then look at it again later, because it's complicated. But I think that given some time and relaxed effort, you will it'll come to you. Good luck.